Okay, so let's go over how mass movement works. Now remember, you have slopes that are stable or unstable, and they're under the influence of gravity, moisture, the composition of the soil. All these things work to have an influence uh, on how these particles will move. So now, mass movement is simply the movement of surface material propelled downward by gravity. That's all it is. And this is usually done on a slope. And the angle of repose is where the material is stable. If you exceed that, then the force of gravity will pull the material downward. So the roll of the slopes, you got the angle of repose, gravity is the driving force downward, but then the resisting force is the strength of the slope material itself, its ability to adhere to the bedrock and to the different particles adhering to themselves. So here's kind of an example. So that's the slope right there. If the angle of repose is exceeded, gravity will pull it down. Now, what triggers mass movement? Well, usually it's the presence of water. Uh, Soils that are, or regolith or bedrock that has lots of clay, shale, or mudstones, they readily absorb water, and that makes them weaker. It lessens the adhesion. The water adds mass, and if you increase the mass, then the force of gravity acts upon it with more strength and will pull it downward. And so this is a good example of that. So you can see, notice this was mostly clay, for example, fills up with water, and the weight, the extra weight of that water exceeds the ability of it to stay adhered to the underlying material, and gravity will pull it down. So all this used to be, well, actually all this up here used to be up here. Now, as we know, living downslope can be a dangerous thing. If you live downslope from this, for example, if there were homes down here, for example, they would have been covered up by this. And this is what happened in La Conchita back in, I forget what year this was, but back in the early 2000s. So make sure and watch this, and you can see how you can actually see it happening, and then see the before and after. And boy, and there was some loss of life there too. And again, that's why you have to be real careful where you live in these cases. So this was a big one not too long ago, actually, where you can see here's the North Fork of the river, and then all this came down and was moving pretty fast, about 40 miles per hour, and the landslide buried, actually changed the course of the river, creating this dam that increased the depth of the water behind it up to 25 feet. And this is in your book, so you can read about that. So you get this failure point where you have altered something in that affects the angle of repose, the geomorphic threshold. And so we reach a failure point. And so we get four classes of mass movements. That mass is going to move somehow. It's either going to fall, it's going to slide, it's going to flow, or it's going to creep. One of those four. This is in your book, so make sure you pay attention to this, and the animations will cover this. So watch the animation; it'll give you, an animated view of how each one of these work. The falls, usually rock, slides, which is usually most moist soil. The flow is larger in volume than a fall or a slide, and incorporates vegetation, rock, and soil. And the creep is just this persistent downward movement of the soil. So the animation in the module, the weekly module or the study area, will go into all four of these and show you how they work. Okay, so fall is strictly rock that falls. And if there's a lot of it, then it's an avalanche. You can see this is strictly just pieces of rock that have weathered and broken apart and have fallen down the slope. Slide, where you have a large amount of material failing simultaneously, can be transitional or rotational. And you can see, so all of this, the reached its failure point and slid down the ground. And this was up here in Afghanistan, northeastern Afghanistan. So either through snow melt or moisture, it added too much weight, exceeded the force of gravity to hold it in place, and the adhesion wouldn't hold it anymore. So we reached its failure point and it slides down. But notice it's way bigger than just individual rocks like we saw in the previous slide. So it just gathers enough force to overcome the ability of it to stay in place. The gravity acts upon it and pulls it down, what we call the glide plane. It'll form the cliff up here, and then this will slide down the slope. And this is the rotational one where it's got a, you can see where it's concave here, so it just, kind of slides down, like a slide on a water slide or something, where it just slides down, okay, into this concave formation here. The flow is where you get very, very high moisture content. Okay, so in this case, there's way, it's the soil mixed with ground cover mixed with water, and it almost forms a river, like a river of this muddy material, and it will slide down, reaches its failure point, and will slide down the slope. Very similar to what happened in up in Montecito last year. And then creep, where it's just this very persistent gradual mass movement, usually associated with what we call freeze-thaw cycles or dry-wet cycles. And often grazing livestock can cause this as well. And again, it's just, the angle of repose isn't very great. But something happens where you expand the surface, and then it'll contract again, or we get slight moisture added or slight moisture removed, and over time it starts to creep down the slope. Okay, so we'll stop here and then we'll cover the human-induced ones in the last part.